Hey everyone, hope you can all hear me okay. So my name is Kaarthikeyan, I am a senior PM at AKS. I'm also going through a bit of resiliency and fault tolerance, having been jet lagged so the last couple of days, but not to worry, I'm mostly surviving on chai and coffee. That's my go-to. Nothing like what you're going to see here. So workload resiliency focused approach. There are three pillars broadly. In terms of platform reliability, upgrades and deployment, that will come later in the day as we go through platform and operator track. But for today and for the purpose of this developer track, I would ground myself into the application resiliency bit, and that's what we're going to focus on. So if I have to break down application resiliency, deployment configurations, you're looking at state management and resiliency bit there. How can we introduce chaos testing to a point where you can test fault tolerance and what is the breaking point for my application, right? And then load testing, which is nothing but a fancy way of saying how can I simulate real world traffic. And that part to do with chaos testing is very powerful to go end to end from scale to fault tolerance. And how many of you here have been subject to some form of workload disruptions, especially when you're going through upgrades, maintenances? Okay, I see some nods as well, but you can also put your hand up, so that's fine. I think many of you, Lucky covered it yesterday as well, if in case you attended the lab. So many of you are not really aware or using what is a very powerful concept in Kubernetes called pod disruption budget. It's a way for you to ensure availability of your critical workloads and pods, and that is by defining what is the minimum availability and maximum unavailability, right? So here is an example there. You can set up PDB. So basically, once the PDB is there, Kubernetes and AKS always honors the PDBs, right? When it comes to evicting the workloads and making sure that your critical pods are available. And then in terms of coming to resource intensive applications, right? You can always use stains and tolerations and try to pin them to the correct set of nodes in terms of mapping pods to the node. So that way you get in terms of managing the intensivity of the applications. Node selectors, node affinity, topology spread constraints are other means to control the scheduling of the pods. I think I probably missed the bit where you, in terms of setting up the request, resource request and limits comes into the picture, especially when you're using things like HPA and VPAs. That's another bit all through we can ensure availability. And how many of you here have actually used Chaos Mesh and Chaos Studio for? Okay, I see one hand up. It's something that we definitely recommend for fault tolerance testing. Azure Chaos Studio uses what is an open source offering of Chaos Mesh. And basically it's nothing but introducing fault tolerance by both at the infra level. You can actually take down VMs, availability zones, etc., or at the deployment and application level where you can choose to kill certain pods, restart, delete, and try to introduce some chaos, right? And thereby push and see where your application breaks and how fault tolerant it is. So it's pretty important, especially you can try it in the lower environment, and as you not definitely recommended jumping into production and doing it, but you can take it phase by phase. Multiple zones for high availability, especially when we are dealing with AKS clusters, you have this concept of zone selection with topology spread constraints, node affinity, and that brings about what we call application level replication. There is also zonal replication with ZRS, which I think Shekhar covered a little bit. So that's important because it helps you to write across the three availability zones. So you can always move zones in case there is zonal level failures with And we're happy to introduce force detach of zone redundant storage, which is now available, and it is what your disk CSI driver adopts when to do the force detach capability. That's quite crucial as we are talking about zonal level redundancy. You can think of ZRS disks. If there is a attached to a particular VM node is impacted with a zonal failure, can quickly recover by moving it into another zone that is available. So this disk force detach is something that you can, yeah, go ahead.
Azure Chaos Studio is pay per use or is it just the add-on?
It is, I think, it is not pay per use as far as I recall, but I can double check. So the question is, what about the billing metrics from? Yeah, I can get back to you later on that. So I have a quick demo where, so I have in a user pool 3 pods which are placed to 3 nodes, and then you have a system pool that is having 3 nodes. So what you're going to do is create in Chaos Studios experiments whereby the first set of experiment is introducing a fault. I'm going to take down specifically selective nodes where my pods are running in the user pool. To start off, you can introduce a custom role with system assigned identity. That's the only thing needed, and then you can create, go ahead and create the experiment in terms of, I'm using node auto provisioning underneath it, and you can see the resilience in action of NAP nodes. I'll probably select a couple of nodes here in the user pool where my pods are placed and take it down. So I'm just selecting a couple of nodes. And the second bit is on the availability zone. So that's the part where on the system pool, specifically I'll try to take down the zones from the system pool and see, because that's where all some of the managed add-ons are running. So see that resilience also in action. So we have topology constraint also put in here and with NAP, and we'll see in action how things get back as we do a chaos experiment. Yeah, selected a couple of zones to take down. It's pretty easy to quickly create. So we've started this, and remember the 3 parts are specifically tied to 3 nodes. So you will see them go unready and quickly come back to ready state. That's the node claim there, and you can see a couple of nodes going to not ready state, and quickly NAP retrieves them back, realizes that it benefits from creating one more extra node here in this instance. So you'll see at the end we're left with 4 nodes. But although as you started on the contours of our deployment, there will be just 3 pods and 3 nodes. And you'll also see that the system pool nodes go from not ready to quickly to ready.
I have a question.
Yep.
So can we capture a report on a portal anywhere as a dashboard, or can we have that metrics capture like a telemetry collector can capture all the metrics and where we can visualize as a dashboard?
Good question. So from Azure Monitor offers a lot of these metrics in terms of looking at node level and container level, but also in terms of dashboard, you have managed Prometheus and Grafana integration available. So that's something you can plug and play with.
Okay. Does it scrape? I mean, does it automatically scrape it?
Yes, you can configure to scrape it, and you can have a real-time dashboard to see all these things.
All right. Yeah. Thank you.
That's a good question. I also mentioned there is Azure load testing, and this is in addition to what we saw in chaos testing. So basically, it's about introducing real-world traffic, user traffic, and it's very easy without any complex infrastructure, similar to Chaos Studio. You can try it out, and basically it works with in tandem with your CI/CD workflows. and it's quite easy to test load regularly or in burst. You can also do bursty traffic and just replicate how a real world situation, just say on Black Friday deals or New Year for some of your applications, how do they react?
Hello, and I hope these can be done through ARM templates or AZ commands, chaos testing and load testing.
In terms of load testing and chaos testing, we have, as far as I know, it's available in Portal. There's good level of this thing. I'm not sure if there's ARM
Because
template on that.
organizations generally they don't allow through portal. There's restrictions, right? So how do we actually go about it then?
Okay, I can check on the
Yeah,
ARM
sure.
template one.
Yeah, thank you.
So as we are going into from a single cluster, if you're looking at a fleet where there is a front door and you have a list of clusters each in a separate region, it's about placing your workload in the right environment and deploying also close to the customer demand. So here we have what we call cluster resource placement, and that helps you to pick from the topology spread constraints what is the right cluster in the right region, so that you can test regional failovers. With that, thanks. I just wanted to say that apps in AKS is as resilient as the local Delhi boy you see in the picture. That's about it. Thank you. And after this, I believe we have Sachi next.